So this should be a kind of nice light one for everyone. I guess quick backgrounds. My name is Christian McHugh. I've been doing DevOpsy type stuff for an awfully long time now. I don't happen to work for Salt or any of the companies that I'll be talking about their products for. I'm just kind of talking about a situation that we ran into and what we did about it. And I thought it would be might be useful for folks. So we can go through it. So I'd like to at least review the tool selection of how we ended up where we were. A little bit of background about SaltStack, what you guys probably might know is a configuration management tool, and its architecture a little bit, because that will inform a little bit more about what we're about to discuss. Go through a little bit of a problem statement and then kind of our solution there. So in the configuration management world, the main big players are usually Chef, Puppet, SaltStack, and Ansible. And I would say in general, I don't really care which one you use. It doesn't matter. It's use one of these things. Make sure that one of these things works well in your environment. And I think that last bit is absolutely key. As we've kind of had a pattern of the speakers talking today about the level of complexity and trying to manage complexity. So how do you validate your environments? How do you check that your environments are doing the things they're supposed to be doing? How do you manage all of that, the tool sprawl and complexity? And when I had an experience years ago working for a firm where we were trying to introduce a configuration management tool. We went through our requirements list and we said, okay, yep, Chef's the one we're going to use. That's going to be great. Everyone's going to use Chef. We picked it. It meets all these check boxes. Good to go. And we went to roll out that tool. And in the process of doing that, we had a dedicated servers team that managed the infrastructure and the OS management for the firm. And that servers team was kind of a bunch of folks who had been doing Linux, Solaris, AX administration for an awful long time. And so when they were going through the Chef training and having to go through use of that tool, we kind of had a rebellion on our hands where that team came back to us and went, well, everybody, it's not going to work. We're Unix admins, we manage config files, and you're having us be Ruby programmers. We don't like it. We're not going to do it. And so we actually ended up going back to the drawing board and going adding more stuff into kind of our requirements gathering and finding out that the usability of the tool wasn't right for that particular place. And so at the time we ended up deploying Salt because it used a slightly easier to get into YAML and Jinja syntax, and our team was more willing to get into that in that they felt it was more like a configuration file that they were able to edit. And so all of the stuff I'm about to discuss with everyone, just keep in mind that this isn't a silver bullet. None of this stuff is, you just do it like this, everything's fine. It really comes down to what works well for your environment, for the people that you have, for the skills that they have, for the knowledge that they have, and your ability to maintain all of that. So let's get into it a little bit. SaltStack as a configuration management tool, it's often put into the configuration management bucket, but it's actually significantly more, and I would argue significantly different. It's ultimately around remote execution. And its remote execution story is pretty good in that it can manage thousands of hosts pretty easily. And so in doing that, it also can manage the configuration of those hosts, because ultimately configuration management is capable of being kind of a subset of the remote execution problem. And so the primary way that you would use Salt is that you'd have an agent, or what they call a minion, that lives on a server someplace. And then that minion checks into a Salt master, and there's a pub subscribe bus that runs that master, and ultimately communication flows. That minion is constantly checked into your infrastructure, and that gives you the very powerful ability to reach out and touch stuff ad hoc and at scale. And so if you're trying to do something like secrets management, where you're trying to distribute secrets into your environment, some passwords or whatever, you often end up with a day zero management problem of how can I verify that the node that's asking for the secret is the node that I think they are. And because Salt has this encrypted channel, if you set up Salt in your environment properly, you get kind of secrets management out of that for free. You already know who's in your infrastructure. You know what those machines are. You've already handled that problem. And so it ends up being a pretty good Swiss Army knife. And so I'm going to get into kind of how we Swiss Army knifed it. So as described, you can have a Salt master, you can have some hosts out there, and all of that stuff is connected. It all works out pretty well. Another component of how Salt is capable of working is that you can have what they call proxy minions. And so what I was just talking about works really well if you control the OS. And so if you're able to install a minion onto that host, that minion can talk into the Salt master and everything talks, and it's fine. You can manage that thing through Salt. It's easy enough. But if you have, say, network switches out there that you're not able to install random bits of software on, well, there's a slightly different pattern for how you might work that stuff. And so there, Salt has an architecture where you have what's called a proxy minion. And so that can be running on a VM or as a Docker container or whatever. And its whole job is to be an endpoint on the network that when it's called through the standard Salt mechanisms, that it then reaches out and talks to whatever infrastructure it needs to through whatever API or process that might be. So for some networking gear, it SSHs in and does the CLI commands thing that it has to do. For an awful lot of stuff, it's more leveraging some of the network libraries and uses their APIs and so on. So great, you can manage all that stuff. And there's also a bunch of other ways you are capable of running Salt. You can have it run through cron and just be an ad hoc job that runs nightly or whatever, but that's not the really interesting stuff that I really want to talk about. So great. So the kind of advantage of Salt and its whole backend is that it has a ridiculously modular code base. So you don't have to wait for a new release of Salt to get some functionality in there. You can actually more or less backport a bunch of that module that you might need that's in the future release, or you can write your own and just put it into your Git repo, and Salt will just use that one instead of its default one, that type of thing. So Salt has what are called execution modules. And in just looking it up for this talk, it turns out there's 531 of them right now, which is an awful lot. And so those are the things that you would run on the command line. So if you SSH into your Salt master, you can target some host and say, host A, tell me about the status of this file. So it could be, tell me about the permissions of it, make sure the files, write this text to this file. You kind of have your building blocks of listing, adding, modifying things. If you want to deal with users, for example, you'd have a users execution module, which will let you add or list or manage users. So great, you have those capabilities on the command line, and that's a way that you could just reach out and touch your infrastructure. And you can do that just as easily on one host as 1,000 hosts. It's pretty nice that way. There's also a component called state modules, and if anyone out there has used Salt Stack before, that's probably most of what you're dealing with is running states on hosts. And those are very similar to the first group, only they manage state. They're little state engines. And so they often use the components that we just discussed. And so if you want to say, ensure that a user account is present on a host, you would run the user states, which would say, ensure that this user is present and have all of your options and arguments and so on of how we want that user configured. And that user state would then probably leverage the user execution module to see, well, is the user already on this host? If it's not, let's add it. If it's already there, then it can return back that it doesn't need to do anything more. If it is there, but it has some different attributes or whatever, it can make sure that those things get modified, return back the results, and so on. And so in my experience in working around Salt, it's been kind of nice because a lot of the problems that we've run into end up being tiny state management problems often in your infrastructure. I just want to ensure that things in the state that I expect it to be in. And so if that's some switch out there or a load balancer or an OS, then Salt gives us kind of this modular architecture to be able to manage those things pretty well. So that's all pretty neat. And then the last big bit of what I would like to discuss really briefly is just that Salt also has different rendering modules. And so when you write some YAML and Jinja that Salt executes on, then that's being run through the renderer. It first runs through the Jinja renderer, and then it will hand it off to the YAML one, and then what gets handed off to Salt is just some Python objects internally. And so that's really nice because they're pluggable. And so if you really hate YAML and Jinja, cool, use Mako or just write it in pure Python if you want. So you have a lot of options there. And so the Salt backend doesn't really care. If you have a render module that speaks that language, it can use it. So that's just pretty nice. In general, folks just tend to stick around YAML and Jinja though. And there's a bunch more. So you can do stuff with auth and external data sources and pulling variables from various places and all kinds of cool stuff, but that's not the purpose of this talk. So I mentioned that YAML and Jinja are typically used, and so this is an example of what that kind of looks like. So at the top here, we're managing a file and we're pushing out this http.conf, and we're ensuring that it's got these permissions and so on. And we have a source where that thing's coming from. So that's your standard configuration management kind of look. If you're using Ansible, would look nearly identical to this, very close. At the bottom, there's a slightly more advanced version where syntax highlighting for Jinja tends to go kind of crazy. And in this case, we have a templated version of something doing something kind of similar. So we're pushing out the message of the day file, the MOTD, and we have a little bit of logic in here to determine where that file is coming from, or to loop over it a couple of times, or whatever it is we have to do. So in general, this is the type of thing that your sysadmin teams would hopefully be pretty familiar with this day and age, that they're able to do this type of thing pretty easily. So great. I mentioned that the whole purpose of this talk was to talk about a problem that we had and what we did with it. And so our solution here ended up being a thing called Saltcheck. And so Saltcheck is just a salt execution module. And so you can, like I said, target anything in your environment. So you can say all hosts that are running this role within the dev environment, I want you to run the Saltcheck validations to run the instruction sets, whatever they are. And so if you run what Salt calls a high states, the be in the state you're supposed to be in, run all of the instructions you're supposed to run to be that host, then Saltcheck can say, well, run all the tests associated with all of those states that we've assigned to that host. Likewise, you could also just say run a single test or whatever. And so that's pretty neat. And the way Saltcheck works is that it just runs one of those Salt execution modules. And so you have all the power and capabilities of whatever Salt wrote an execution module for, you are able to validate that thing's output. And so to use the user example from earlier, if you wanted to see, well, I should have added 1,000 users and these SSH keys to all of these hosts, did it get done properly? So Salt said it did, and it came back and said everything's okay, but maybe you want to double check and validate that. And so Saltcheck can be used to do that kind of job. You can just have a little test script that says, see if the user module returns back the information that I expect it to have. But the really nice thing about it is that it uses the Salt rendering system. So that YAML Jinja stuff that your sysadmin teams might be familiar with, it uses that language already just the same way. So if you happen to be a Salt shop already, then Saltcheck makes it pretty easy to start using that thing too. Salt has the concept of variables on a host. It calls them grains. It's kind of like variables from Ansible or the OHI stuff or from Chef, but just the information about a host that you can also be appended. You have access to all of that stuff in Saltcheck as well, or your external data sources, or those secrets that Salt's managing. So it's just being able to leverage the power of this fairly rich ecosystem means that you can do a bunch of stuff. So those tests end up looking something like this. This is a short, simple version, but it's pretty similar to the Jinja YAML stuff we were looking at a little bit ago. So at the top here is an example of just a simple check where we're going to run the package.upgradeAvailable execution module. And we're going to pass along the Apache 2 arguments. So this would be a Debian host, it looks like. And so we can see, does my Apache 2 package have any updates available? And we're going to run an assertion here and say, well, it shouldn't, otherwise the test should fail. And so that's a pretty quick test to see, is there a security update or whatever for my Apache package? And likewise, down at the bottom there, there's a fairly equivalent one of checking Apache 2 and OpenSSH. And we're doing that in a Jinja for loop just to test multiple things. And just the demonstration here is just showing off that the YAML works in the top one and the YAML plus Jinja work in the bottom case. And at the very top there, that's an example of the command line that you might run to test some of your stuff. And so the Salt command line looks something sort of like that. That would target all the hosts in your environment and say, run all the tests associated with your environment. So great. So now the problem that we had was we had environments where we were spinning up these very large Hadoop clusters on a regular basis. So we had our production environment, we had our QA environments, we had various UAT environments, we had a lot of dev environments. And for something like Hadoop, it's capable of being incredibly complicated. And so the problem we ran into was whenever we changed some stuff in our environments, maybe that was our AWS provisioning code that we were doing in Terraform, or maybe it was some sort of ACL bits we were doing to change how we were securing our data sets, or we were uploading new versions of data sets or new code or whatever. All of that stuff, it's just a ton of things that you have to manage and track, and it gets really complicated. And in a really large development shop, when you're trying to manage a lot of things between a lot of teams, there's a lot of friction between all of those teams. And so the problem that we had was really that there was a lot of change happening. That change was hard to manage. We had a dedicated QA team, but the QA team effectively couldn't really keep up very well. That whenever we provisioned one of these clusters and there was a problem, the QA team had to get on it, and they had to run through the same script every time. And so they had to check, is this Hadoop file have been provisioned properly? Is this config file been provisioned properly? Are these users in the right state? Are the various mount points accessed appropriately? Are these network ports open between these nodes and the clusters? Is this database available? Are these other AWS endpoints provisioned correctly for this one environment versus this other environment? And so all of those special edge cases and features and all the stuff that they had to deal with just ended up burying them. And so it just took them a ton of time to be able to validate these clusters. And if you're spinning them up regularly, you don't really want to spend time having that team get buried, and it's not really a good experience for anyone. And so as an example, we had problems with some of the things that I mentioned here: user management, data state, network connectivity, all the big, I provisioned a big cluster kind of issues. And so our solution there was we wanted to be able to save them time. And so we ended up deploying Saltcheck, the thing I've luckily been talking to you about all this time. So great. Here's a fairly short example of what one of those Saltcheck tests might have looked like for our Hadoop cluster. So there happens to be a Salt execution module for Hadoop and the Hadoop file system backends that it has. So there's this Hadoop DFS present reports back if that file exists within the Hadoop file system. And so we can pass along a particular file where that file has some variables that come from some external data source. So depending on how we provision that cluster, they would have different versions of things. Those versions of things we saved in the Salt grains, the variables that we kept on the hosts that Salt had access to. And in that way, we had a really, this ended up being a really good solution for us where it was really cohesive. We could have our provisioning code do the provisioning process. It managed this thing pretty well. And for our QA teams that had to validate, are all of these things okay, they were able to write some of the tests like this. Or at the very least, they were able to describe what their tests should be. And the sysadmins who were familiar with this environment were able to write these tests without too much of a problem. And that's really the secret sauce, I think, behind a lot of this stuff, because we end up with a lot of different tools, and there's a lot of different options that you have out there. There's a lot of different ways that infrastructure can go. And you need to make sure that you're doing a thing that's maintainable for you all in the long run. And so what was really advantageous for us is kind of like my chef example from the very beginning. We were able to leverage the existing nomenclature and syntax that a lot of our teams were familiar with in order to use those tools even more than what we originally intended for them to be used for. So it was nice in that it reduced our maintenance burden. So here's an example of talking to a Hadoop file system backend. Likewise, we can test the contents of the Hadoop files themselves. This would be slightly complicated to do just in a shell script or something. And so here we can use the Hadoop DFS, Hadoop.dfs to output the text of the file and then do an assert not in. And so this is a way that we were able to validate this one config file to see, is it in its default state? Has it not been provisioned? Is there some issue with the config file that it should never be in this state? So hopefully that never occurs, but it's a quick validation just to check that one off the list and go, nope, we know that that one's okay, move on to the next potential problem. Likewise, you can do some user management stuff. So here's an example of iterating over our external data source, which is this pillar.get thing at the very top. And so there's some place that we kept a list of users. That could be S3, it could be a Git repos, whatever it was. But we kept user information that we wanted to provision to our environments. And so we had a list of users, SSH keys that should be associated with them, and so on. And so this is a check that is nice because it's integrated into Salt the way that it is. It allows us to use those same Salt components and backends. So in this case, the same place where we kept, here's the list of users that should be provisioned, we're able to take that same list and then validate against it. So again, reuse of the tool. We didn't have to rewrite the export of that data to run our checks later. We can also do things like check S3 and validate that our data is in the state we expect it to be in, ensure that the files are there, they contain the right things. You can just full on run commands if you ever need to. And so in this case, we're running a Python executable just to validate that the Bodo3 library is in the installation state that it's supposed to be and so on. So the power is really up to you, and that whatever you need to do, you have a lot of capabilities out there to get it done. The other component of all of this, I guess, is in my experience, you often want to centralize or control the places where you invoke change. And so Salt, being the excellent remote execution tool, makes that pretty nice. And that we could say anything that gets adjusted on that host has to go through this path. So if we're going to say deploy files and restart services, then we would just have a deployment state and push that out to our hosts as we needed to. We'd have the initial build of hosts and do the classic configuration management story. Likewise, a lot of this stuff can be tied into Jenkins. And so we use Jenkins quite heavily in that shop for our deployments and CI pipelines. And so as part of that, we would have examples sort of like this, where this is an example of using the Salt plugin for Jenkins. I guess, quick aside, I happens to be the author of that. So if there's any problems, please fill out bug reports and so on. But we were able to use this pretty nicely in that we could have Jenkins do whatever build job it wanted to do. And when it came to deployment time, it could kick out to our external agent of change, the Salt, in this case, Salt API, and make sure that that state got deployed and that application got deployed utilizing Salt states. And then the bottom line there is just running a Saltcheck run test against it as well. And so as part of our CI pipeline, we could both deploy the thing and validate a bunch of stuff about our environment utilizing the same suite of tools that we're already comfortable and familiar with. And so again, just try to reduce your maintenance burden as much as possible. So overall, as a summary, Saltcheck was able to, we were able to leverage remote capabilities of it so that we were able to reach out and touch infrastructure, some of which would have been really difficult for us to do otherwise. And it was important that we were able to utilize this tool in particular because it kept the same familiar markup and the same data sources. Overall, you want to have a pattern of just reuse and knowledge reuse and sharing kind of design patterns. You don't want to have every team necessarily invoke their own special snowflake every time, so that when you're trying to introduce that team introduce, say, standards around monitoring or deployments or configuration, you want to make sure that those things are done in a way that everyone kind of understands them, even if they don't understand everything about the tool, that they're at least familiar with these patterns and designs. And so leveraging Saltcheck in this case allowed us to do that type of thing. It made it easier for us to get through this, this validation problem that we had. And overall, kind of echoing what some of the previous presenters have been speaking about as well, having been doing this computer gig for a while, we're not getting any, we're not getting any less specialized. That the IT world is forever becoming more and more specialized in language choice or build chains or deployment topologies or server methodologies, and just everything about this industry is larger than it ever has been before. There's more stuff to learn like never before, and you have a benefits of so many riches out there of what to choose. And so overall, I'm not saying everyone out there has to use Saltcheck. That's not really the important bit. It's utilize something that your team understands. That's the hardest part. That everyone can go out there and read a blog post and go, oh, here's the cool new shiny thing. This thing's awesome for these reasons. And ultimately, it all comes down to what can you support for your customer base and how effective can you be? And so in general, we all have teams with limited resources, limited capacity to learn yet another thing. So just try to leverage your existing skills, your existing knowledge to be able to get through all the maintenance that you'll have in this massive tool sprawl. So for us, Saltcheck ended up being a really useful tool, really helped with validation for all the reasons that I mentioned. It may or may not be good for you, but I figured it was at least worth a look and worth the conversation. So that's all I've got. Thanks very much.